A cylindrical bar is 25 mm diameter and 1200 mm length, subjected to tensile force. The longitudinal strain is 4 times the lateral strain. Find the change in volume when the bar is subjected to a hydrostatic pressure of 125 Newton per mm square. Also find the rigidity modulus if E is equal to 1.2 into 10 to the power of 5 Newton per mm square. So here there is a cylindrical bar, its diameter is 25 mm. So there is a cylindrical bar, and its diameter is 25 mm. Its diameter is 25 mm. So diameter of cylindrical bar is 25 mm. Next, and 1200 mm length. So length of cylindrical bar, length L is equal to 1200 mm. Length of cylindrical bar is 1200 mm, subjected to a tensile force. Okay, so and longitudinal strain is 4 times the lateral strain. Here longitudinal strain generally denoted by epsilon L. So longitudinal strain is 4 times of lateral strain. 4 times of lateral strain. Lateral strain generally denoted by epsilon D. Okay, no? Here lateral strain means diameter strain. So longitudinal strain is 4 times of lateral strain. And next, find the change in volume. So we have to find change in volume of the cylindrical bar when the bar is subjected to hydrostatic pressure. So this bar is subjected to hydrostatic pressure. This bar is hydrostatic pressure. P is equal to the given 125 MPa, nothing but 125 Newton per mm square. Means 125 Newton per mm square. Okay. Also find modulus of rigidity. If Young's modulus E is equal to, so we have to find again modulus of rigidity. So rigidity modulus or modulus of rigidity denoted by capital G, and take E is equal to, given E is equal to 1.2 into 10 to the power of 5 Newton per mm square. So these are all given data. Okay, now given this much data. So anyhow we need to find two quantities. One is change in volume, and one more thing is modulus of rigidity. So change in volume find out cheyali, modulus of rigidity find out cheyali. Here there is a cylindrical bar, its diameter is 25 mm and the length of cylindrical bar is 1200 mm, subjected to tensile force. So the cylindrical bar is subjected to tensile force. Okay, now due to tensile force there is a change in length and there is a change in diameter. Okay, tensile force apply cheste emotundi, there is a change in length. So length increases, since it's a tensile force, length increases, diameter decreases. Length increases, diameter decreases. Okay, now given relation, lateral strain is equal to 4 times of longitudinal strain is equal to 4 times of lateral strain or diameter strain. Longitudinal strain generally, what is longitudinal strain first of all? Longitudinal strain is equal to change in length by original length. Longitudinal strain or normal strain is equal to change in length by original length. And what about diameter strain, lateral strain? Change in diameter by original diameter. Change in diameter by original diameter. Okay. So what is the relationship between lateral strain and diameter strain? Poisson's ratio. So Poisson's ratio is equal to, what is the formula for Poisson's ratio? Poisson's ratio is equal to lateral strain by longitudinal strain. Lateral strain by longitudinal strain. So from this relation, so epsilon, from this relation, actually epsilon L is equal to 4 into epsilon D. Now from this relation, epsilon D by epsilon L is equal to, So transpose for multiplication becomes division. You will get 1 by 4. So this 1 by 4 is equal to what? Epsilon d by epsilon L means Poisson's ratio, nu. Okay na? So here he actually given Poisson's ratio. Okay, indirectly given Poisson's ratio. Poisson's ratio how much? 1 by 4. The value is 1 by 4. Okay, next let us see how to calculate volumetric strain and shear modulus of rigidity or shear modulus. Okay na? So anyhow, here hydrostatic pressure given, Young's modulus is given, diameter length is given. Okay, let us calculate the change in volume and modulus of rigidity using this data. First of all, let us calculate shear modulus or modulus of rigidity. Okay, what is the relationship between shear modulus, Young's modulus and Poisson's ratio? What is the relation? From elastic constants concept, G is equal to E by 2 into 1 plus mu. So now G is equal to Young's modulus. E for Young's modulus. Young's modulus how much? 1.2 into 10 to the power of 5 Newton per mm square. Anyhow, Poisson's ratio has no units. So 2 into 1 plus. Poisson's ratio how much we got? I think we got 1 by 4. Okay. Next, Z is equal to 2 ones to 0.60. So 0.6 into 10 to the power of 5 by 4 ones are 4 plus 1 5 by 4. So reciprocal of 5 by 4 4 by 5. Okay. G is equal to 4 into 0.6 by 5 into 10 to the power of 5 Newton per mm. Okay. So let us simplify further. Now Z is equals to 4 into 0.6 2.4 by 5 into 10 to the power of 5 Newton per mm square. Z is equals to 2.4 5 ones 5 0 point, okay, 428. So 0.48 into 10 to the power of 5 Newton per mm square. So G is equal to, still we can written as 0.48. 10 power 5 can be written as 10 square into 10 cube Newton per mm square. 0.48 into 10 square you will get 48. 10 cube Newton means 1 kilonewton is equal to 10 cube Newton. Kilo means 10 cube. So 48 kilonewton per mm square. Therefore, shear modulus or modulus of rigidity is equal to, rigidity modulus is equal to 48 kilonewton per mm square. Next we need to find change in volume. So what is the relationship between change in volume and hydrostatic pressure, and I think one more elastic constant, bulk modulus. So we know that bulk modulus K is given by, K is equal to E by 3 into 1 minus 2 nu, as well as it has one more formula, direct stress by, nothing but dP, hydrostatic pressure, direct stress by volumetric strain, direct stress by volumetric strain. Volumetric strain means change in volume by original volume. We need this change in volume. Here dP means hydrostatic pressure. So it has two formulas. So first of all, here we need delta V. To get delta V, we need V, that means volume of the cylindrical bar, and also we need bulk modulus. So we can find bulk modulus from this formula, because we already have Young's modulus and Poisson's ratio. Using this formula, first of all let us calculate K value, then we can find the delta V. Okay, so bulk modulus K is equal to E by 3 into 1 minus 2 nu. Okay, this is the formula for bulk modulus. So relationship between Young's modulus, bulk modulus and Poisson's ratio. Okay, no? K is equal to, so here I am going to calculate K value. E already given, how much? E is equal to 1.2 into 10 to the power of 5 Newton per mm square by 3 into 1 minus 2 nu. Poisson's ratio how much? 1 by 4. So 2 ones, 2 twos. K is equal to 1.3 ones and 3 0.8s. Not 0.8s, 3 0.4s. 3 4s are 12. So into 10 to the power of 5 by 1 minus 1 by 2. So 1 minus 1 by 2, how much? Again 1 by 2. So 0.4 into 10 to the power of 5 by 1 by 2. Reciprocal of 1 by 2, 2 by 1. So 2 by 1 into 0.4 into 10 to the power of 5. 2 into 0.4, how much? 0.8. So 0.8 into 10 to the power of 5 Newton per mm square. Again 10 power 5 can be written as 10 square into 10 cube. 10 square into 0.8 80 and 10 cube into Newton kilo Newton per mm square. Therefore bulk modulus of the given material is 80 kilonewton per mm square. Okay. So next we need volume of the cylinder. Here V means volume of the cylindrical bar. Volume of cylindrical bar. We need volume. Then only we can calculate change in volume. Volume of cylindrical bar is given by pi by 4 into, what is the formula? Pi by 4 into d square into L. Okay, generally we take pi by 4 into d square into h. So here height means length. Pi by 4 into diameter is 25 mm. So 25 square into length 1200 mm. So you will get volume in mm cubes. So V is equal to pi by 4 into 25 square means 625. 25 is to 625 into 1200. 4 1s, so 4 3s 12, so 4 300. V is equal to pi into 625 into 300. If you calculate, you will get approximate value 589,048.62 mm3. This is volume of cylindrical bar. Using these two values, we can find change in volume of the cylindrical bar. What is the formula? One more formula for bulk modulus. Bulk modulus is equals to hydrostatic pressure by volumetric strain. So delta V by V, change in volume by original volume. Okay. So reciprocal of delta V by V, V by delta V. So V into hydrostatic pressure. Okay. dP means hydrostatic pressure by delta V. Change in volume. So just interchange positions of K and delta V. Okay, now you will get delta V is equal to, multiplication becomes division. You will get V into dP by K. Delta V is equal to volume, how much? How much we got? Volume 589. Volume of cylindrical bar 048.62 into hydrostatic pressure given 125 Newton per mm square by bulk modulus 0.8 into 10 to the power of 5 Newton per mm square. So if you calculate, you will get change in volume. So approximately you will get 920.388 mm cube. So therefore change in volume of cylindrical bar is 920.388 mm cube. Okay.